Hey guys, Miss Pariseau here. Sorry I couldn't be with you on Tuesday and again on Wednesday. I just wanted to make sure you had everything you needed from Tuesday's assignment. This was where we left off, and I had left this up, the page number that you could find it. So I just wanted to make sure that you knew what to fill in. So we can tell that a graph is going to open up if the A value is greater than 0. If the A value is less than 0, it's going to open down. And then if the absolute value of A is greater than 1, then it's going to become steeper. It's going to stretch and get skinnier. And if the absolute value is less than 1, like between 0 and 1, like as a fraction, it means that the graph is going to get flatter. It'll compress. It'll shrink. And then we saw that the C value, the constant, was told us if we are moving up or down. Okay. So I had asked you guys to do page 240 and a select few problems. So I wanted to go ahead and just go over them real quick. I'm not going to go over every single one. I'm actually going to have you pause the video and try, like if you haven't tried it on your own, go ahead and try it. But I will work through one of them with you. So as you can see, I've already done number 21. So I'm going to pick up with number 23. All right, now I could probably start filling this out over here before I even start graphing it, just based off of a couple of things, right? I know that here, if I take a look at my A value, it's going to open down, right? It's going to open down because the A is less than 0. And then, so if it's going to open down, excuse me, I know I'm going to have a maximum. I don't know where that point is just yet. But if it's going to open down, that means that I was going up and then I turned around and came down. All right, so I can figure that out from there. And then the other thing I can also figure out is if it's going to be steeper, flatter, or the same. Because I can look at my A value. And the absolute value of my A value is 3. So that is greater than 0. So it's going to be steeper in comparison to the parent function, which is here. All right, so what I'm going to do, remember I told you from this one, there's not too much that we can graph. We could get the y-intercept as well, because the y-intercept is when x is 0, right? So when x is 0, what's the y value? Well, that's going to be 4. So we have one of those points, but that's really it. That doesn't really tell us any more, when we can't really get anything else out by just looking at the equation. So we're going to plug in some values, and remember I told you a good place to start is like -2, and using those anchor points that were from the parent function. So, and you kind of have to play around with it. So I went ahead and I tried -2, and when I plugged in -2, I got -20, -1, got -5. Excuse me, 0 was my y-intercept at 4. When I plugged in 1, I got out a 7. And when I plugged in a 2, I got out a 4. And so right there, here I can see, notice I went 0, 4, 1, 7, and then now I'm back to that 4. This tells me this must be my vertex. This is my turning point right there. And I went ahead and extended it, and I went to 3 and -5, just to try to get some symmetry happening. So I would say I can't graph -2 and -20 here. So I'm going to go ahead and go -1 and -5. 0 and a +4, 1 and 7, 2 and 4, and 3 and -5. And we can see we have this symmetry happening, right? So that tells me that my line of symmetry is right here. So my axis of symmetry is going through the value x equals 1. And both of those points are equal distance from that line of symmetry, that axis of symmetry. So now I can go ahead and just connect my dots. I'm doing a great job here. All right, so we get the shape of it, and we can see that our domain, it's still all real numbers. But our range is different, right? With the parent function, it was at 0 and going up. Now, if we start, again, range is the lowest. So the lowest it goes is negative infinity, and then the highest it goes is 7. And 7 is included, so we're going to have a bracket, and we're going to have a parenthesis around that negative infinity. My vertex is 1, 7. All right, and now here, my x-intercepts, it's not really clear, so I'm just going to estimate it. Because in this form, and with this graph, I can't really say for exactly. I have to go through and do the factoring and the quadratic formula to get the precise ones. So I'm going to say it's about negative 1/2, and it's between 2 and 3, so I'm just going to estimate it around 2.5. And my maximum is my vertex, so I'm just going to record that again. So that's the idea behind how to approach these. So what I'm going to do is, if you haven't done them, I'm going to go ahead and finish up on here the 25, 27, 31, and 34. And when you're ready, you can come back and check the video so you can check your answers. All right, hopefully you're back to check your answers. Here is number 27. I went ahead and highlighted the axis of symmetry just so you could really see how the points are equal distance from it each time. I also just made sure that when I was saying it's steeper, I just gave the reason why, because the absolute value of the A value was greater than 1. And so as you're working, just be mindful and pay attention to some of the similarities between the original parent function. Okay. Also, remember, see what you can figure out based off of just looking at the function before graphing it. So, for example, in number 31, I see that the A value is 1, so I know it's going to have the same shape as the parent function. And the only thing that's different is that it's shifted down 1 spot. So that's about it. Now you'll notice here in number 31 how I wrote my x-intercepts. Because there was more than one, I wrote it in the little bracket as a set. It's just saying the set of negative 1 and 1. That's just what that means. Okay. And then for, again, pause these so you can take a look and check your answer at any time. All right, and then for number 34, again, we can see that because of this -3 right here, that the parent function is going to shift down 3 units. And this 3/4 means that it's going to get a little bit wider. Now my graph, notice the values that I picked. I didn't pick -3 or -1. And the reason for that is because of this denominator. I know that whatever value I get after I square it, I'm going to divide by 4. So that's why I stuck with my even numbers, because I knew that if I used 3 or 1, I was going to get like a decimal. And so I just kind of skipped doing that. Now that might have impacted the shape a little bit more, and it might be harder to see that this got a little bit wider, but we can also see it here that it looks a little bit wider than the original. So hopefully that will help explain what the expectations were for that first unit.